There is a technology quietly moving out of university labs and into real data centers right now. And if you work in IT or you are trying to rebuild career in tech, this is something you genuinely need to understand. Not because it is hype, but because the last two times the technology made this kind of jump, the people who paid attention early, whether as investors or as professionals, came out in a completely different position than everyone else who waited. I spent years in IT infrastructure and tech consulting. I have watched trends come and go, and I want to be honest with you from the start. Quantum computing has had a reputation problem. For years, it felt like something that was always 10 years away, but three things just happened within the same week that changed how I personally think about this space. Let me take you back to early 2025. Jensen Huang, the CEO of NVIDIA, stood in front of a crowd at CES in Las Vegas and said that useful quantum computers were probably 15 to 30 years away. The market reacted instantly. Quantum computing stocks collapsed. One dropped by nearly 40% in a single day. Another fell by 45%. It was brutal, and a lot of retail investors got burned. And then something interesting happened within 2 months. Jensen started changing his tone. By mid-2025, he was hosting NVIDIA's first ever Quantum Day. A few months after that, he was saying quantum was reaching an inflection point. That kind of reversal from someone like Jensen Huang does not happen by accident. Something was clearly moving behind the scenes. And now we know what it was. In the space of just 1 week, 3 separate breakthroughs happened that moved quantum computing from research project to investable, practical technology. First, NVIDIA released an open-source software toolkit called iSync. This is designed to split computational problems between classical GPUs and quantum processors, getting the best performance from both at the same time. Second, a company called IonQ announced the world's first photonic interconnect between 2 separate commercial quantum processors. In plain language, they linked 2 quantum chips together and made them function as one. This is something the industry has been trying to do since the 1990s. Third, a company called Rigetti made their 100-plus qubit quantum processor available on Amazon Web Services, meaning any developer, any startup, any enterprise in the world can now rent time on a real quantum computer the same way they rent a cloud server. 3 breakthroughs, 1 week. If you have a question about how quantum computing might affect your specific IT role anywhere in the world, drop it in the comments. I read every single one and I will answer as many as I can. I know some of you are watching this are investors, some of you are IT professionals, some of you are both. So let me explain this in a way that is useful for all of you. A classical computer works in bits. Every piece of information is either a 0 or a 1. Every app on your phone, every cloud server, every AI model you have ever used runs on that simple foundation. Billions of ones and zeros flipping every second. A quantum computer works with qubits. A qubit is not just 0 or 1. Before you measure it, it carries a probability of being both at the same time. When you link multiple qubits together through a process called entanglement, something extraordinary happens. Mathematically, 300 entangled qubits can represent more possible states than there are atoms in the observable universe. That exponential power is what makes quantum computers fundamentally different from anything we have built before for specific types of problems. Those problems include optimization, cryptography, material simulation, and certain kinds of machine learning. These are not abstract problems. These are exact problems that logistics companies, pharmaceutical companies, financial institutions, and defense organizations are actively paying to solve right now. For IT professionals, here's why this matters to your career specifically. Hybrid computing is coming. The future is not quantum computers replacing your servers, it's quantum processors plugged into existing data center infrastructure, alongside CPUs and GPUs to handle specific workloads. NVIDIA has already built the infrastructure layer for this with the NVQLink and their CUDA stack. Companies that are early in understanding how to deploy, manage, and integrate quantum workloads will have a serious advantage. The EU has already committed billions to the quantum flagship program. Germany, in particular, has invested heavily through institutions like the Fraunhofer Gesellschaft and the Jülich Supercomputing Center, which houses some of Europe's most advanced quantum hardware. If you're building a career in IT infrastructure, cloud, or cybersecurity in Germany or Europe, quantum literacy is going to separate candidates sooner than most people expect. And if you're watching this and thinking about how to upscale, I will come back to this. But first, let me explain the investment side, because understanding the companies involved also helps you understand where the industry is actually heading. If this kind of content is useful to you, hit the like button and subscribe. It genuinely helps this channel reach more people who need this information. The three public traded quantum computing companies worth understanding right now are IonQ, Rigetti, and D-Wave. Each one represents a completely different technical approach, and that is actually important because no one yet knows which approach will win. Let me walk you through each one by one. IonQ uses what is called a trapped ion system. It captures charged atoms using electromagnetic fields and controls them with lasers. This approach produces very high quality qubits, fewer errors, longer stability. They run slower than some alternatives, but they are the easiest type to network together. That matters enormously because scaling quantum computing requires connecting multiple chips, not just building one giant chip. Last year, IonQ reported $62 million in revenue in a single quarter, up over 400% year over year. They crossed $100 million for the full year, making them the only public quantum company to hit that milestone. Their backlog sits at roughly $370 million, and DARPA, the US Defense Advanced Research Projects Agency, recently selected them for a 2-year program specifically focused on scaling quantum systems. If you are an investor looking for the company with the clearest product market tractions in this space, IonQ currently has the strongest case. Rigetti takes a different approach using superconducting circuits, tiny electrical loops cooled to near absolute zero that behave like artificial atoms. This method is faster in raw terms but harder to keep stable. What makes Rigetti strategically interesting is that they are already integrated into NVIDIA's hardware stack via NVQLink. If enterprises want to build hybrid GPU, quantum workflows using NVIDIA infrastructure, Rigetti is the natural partner. And their processors is now available on AWS, which puts it in front of millions of developers worldwide. Their revenue is still very small, around $7 million for the full year, but they have roughly $590 million in cash, which gives them years of runway to grow. This is a pre-commercial bet on NVIDIA's quantum ecosystem. D-Wave is the most commercially mature of the three. They already have paying customers. Volkswagen, Google, NASA, and Lockheed Martin have all used their systems. D-Wave uses quantum annealing, a specialized approach optimized for solving complex optimization problems, not general-purpose computing, of course. Earlier this year, they also acquired a company called Quantum Circuits, giving them a second architecture under one roof. Their full-year revenue for 2025 was around $25 million, up to 179% year over year. And in just the first 2 months of this year, they booked $32 million in new contracts, more than their entire previous year's revenue. D-Wave is the option for investors who want a company that's already generating real commercial demand with 2 different technical bets running simultaneously. The most immediate impact of quantum computing on IT careers is in cybersecurity. Quantum computers, once they reach a sufficient scale, can break most of the encryption that currently protects the internet. RSA elliptic curve cryptography, the protocols that secure banking, healthcare, data, government communications, they become vulnerable. This is not a distant hypothetical. The US National Institute of Standards and Technology finalized its first post-quantum cryptography standards in 2024. The EU is actively pushing organizations to begin migration planning now. In Germany, the BSI, the Federal Office for Information Security, has already issued guidance on quantum-safe cryptography transitions. This means there is an emerging demand for IT professionals who understand quantum-resistant security frameworks. If you're working in cybersecurity, cloud infrastructure, or enterprise architecture in Germany or Europe right now, adding post-quantum cryptography knowledge to your profile is one of the most forward-looking moves you can make. Certifications and training in this area are already available throughout NIST, ENISA, and various European academic institutions. I put the links in the descriptions below. If you're very young and starting your university, please do your research. Read articles about quantum computing every day, every single day, and see whether you like to jump to this educational path or not. Beyond cybersecurity, roles in quantum software development, quantum cloud operations, and hybrid infrastructure management are beginning to appear on job boards, including in Germany, the Netherlands, and the UK. The Fraunhofer Institute, DLR, and startups backed by the EU Quantum Flagship funding are already hiring. The talent pipeline is years behind the technology curve. That gap is your opportunity. And if you want a concrete starting point, IBM Qiskit, Google Circ, and Amazon Braket all have free learning resources that teach you the fundamentals of quantum programming without requiring a physics PhD. I will put the links in the descriptions below. You do not need to become a quantum physicist to benefit professionally from this wave. You need enough literacy to understand what's coming and position yourself ahead of the organizations that are still ignoring it. Before we go to the final takeaway, if you have a question about how quantum computing might affect your specific IT role in Germany or Europe or anywhere in the world, drop it in the comments below. I read every single one and I will answer as many as I can. So here is where we are. Quantum computing is no longer waiting for a breakthrough. The breakthrough just happened. NVIDIA has built the infrastructure layer. IonQ has proven that quantum chips can be networked together. Rigetti is on AWS. D-Wave already has enterprise customers across their continents. And Europe is not sitting this one out. Germany in particular is investing seriously at the institutional level. From an investment perspective, these companies are high risk, high volatility, and still small in revenue terms. But the growth trajectories are real. The technology milestones are accelerating, and the market is expected to grow at over 35% annually for the next decade. If you are an investor, you are not late, but you are also not early anymore. From a career perspective, the window to build a quantum literacy before it becomes mainstream, demand is still open, but it is not going to stay open forever. The organizations that start preparing their IT teams now will have a significant advantage over those that will wait until quantum computing is already in the headlines every day, like the AI. The last two technology eras, mobile and AI, both created enormous opportunities for people who paid attention early, not just investors, professionals, engineers, and career builders who choose to understand the technology before it was obvious. This is that moment again. If this video helped you think about your career or your investments differently, subscribe to the channel and leave a comment below telling me whether you are more focused on the career side or the investment side, and give me your idea. What do you think about the investment? I read everything and it helps me make more of the content that's actually useful for you. See you in the next one.